So welcome everyone. This is the last session of the day, and it's going to be on Zero Trust Network Access and what it is not, and I will give you recommendations if you are evaluating this technology for use in your own area. It might fall under the blanket of secure access, right? This is something that the industry is looking into a lot. So a bit of myself, I am actually Jeff. I take care of the incubation team in the APJC region. I've been around for about 15 years. I'm a foodie, so if you've got recommendations for good sticks, let me know after the session or join the WebEx Teams room and we can have a discussion, right? So today I'm going to talk about why we need ZTNA, how it came about, how to evaluate this technology, and we are going to dive into what are the options, right? We have this on the Cisco Secure Firewall, we have this as the DNG from Duo, and the new new solution that we have is the Cisco Secure Access. So this is the latest and greatest offering from Cisco to provide a way for us to securely connect into our applications. So why do we want to move towards a ZTNA? So first of all, is Zero Trust, right? Zero Trust has been pushed by Gartner to all our applications, to all our users. And why do we want to do this? The perimeter has changed, right? Identity is the new perimeter. Users are hybrid, they're everywhere, they're no longer in the data center. Our apps are no longer sitting only in the data center, they are in the cloud. And that has caused us to effectively expose ourselves to a lot of attacks. Today, I can use a credit card, dark web, phishing attack to the users. And how can I make money from this? As an attacker, cryptocurrency. Right? I don't care where the users are, just pay me in cryptocurrency. Ransomware on your endpoint. Is your data important to you? Yes, it is. And you would pay me in order to get access to that data. We have done a study with about 6,000 customers, and we found that 80% of these customers are not equipped to deal with such threats. So this is very, very concerning, right? Whether it's a resource crunch solution that is not fit for the organization, we want to change the way users access. And that brings us to ZTNA. It's actually two conflicting principles, if you think about it. Zero Trust always talks about least privilege, identity-centric, around applications, continuous verification. On the other side of the house, if you have a traditional network, what do you use? ACLs, static keys, right? And as long as you are validated, I authorize you to access the entire network. So when we put these two together, it becomes very, very powerful. Why do I say that? If you have a privileged access management solution, do you only think about just a one-time password reset to the user for the admin for one time only? Or do you think about it from the network perspective? I encourage you to think about this from the network perspective. And if you are evaluating this as part of SSE, right? Many customers are looking into this today. I would encourage you to think about the strategy. Is your strategy to have ZTNA standalone because you have one specific use case of, I have an application, I do not want to turn my firewall routing upside down, I just want a ZTNA for this one application? Or is your use case, hey, I want a strategy for longer term, align with my SSE, align with my SASE strategy. One single vendor, one single platform to manage all the security of all this. So these are the things that you want to consider. Second use case. So this is a study done by Gartner, and this is the recommendation that they have. Internal workforce. So this is bread and butter, right? Users are now remote. At the office, at Starbucks, at home. They want to access their applications. How do you provide this to them? Are you using NAC on your internal network? Are you using VPN remotely? Is there a way to unify this all together? Yes, there is. The other use case that you need to think about is BYOD. You need to think about how this is going to have an impact on your end users' devices. You need to think about contractors. And you also have partners coming into the environment. How do you provide limited access to these devices that you cannot control, cannot install software, as well as privileged users? So you have developers in your company. You have certain users that might need SSH RDP. These are privileged users, privileged access, specific data sets. How do we actually enforce Zero Trust while doing this in a remote hybrid environment? And finally, on-premise access. This is quite interesting. Okay? So the concept of this is you have NAC in your environment. However, as long as the device is connected to an access switch, I should be able to spread this across my WAN, my LAN, and it should be integrated. It should just be a networking fabric in which you have secure connectivity wherever you are connected. So these are the use cases that Gartner calls out, and you have the opportunity to address with a ZTNA solution. Finally, platform. So are you using a single platform to actually unify both your ZTNA, your RBI, your DLP, all in one with a single policy set? Or are you actually going to vendors? So I will explore further down the road why it is advantageous to actually have a single vendor, single client, single policy to manage all this. Visibility and control. So this is the other thing that I want to call out. So let's say you go with a traditional VPN and you actually employ a ZTNA solution in your environment. What happens? Traffic acquisition on your endpoint becomes two-path. I do not have visibility to actually manage security for these two elements concurrently, right? And I'm not able to actually introspect both traffic at the same time to actually do security operations. The other part of it, if you are doing ZTNA and VPN at the same time, how are you intercepting that traffic? What happens with most vendors is A, I will use the ZTNA client to intercept that traffic coming in and decide if I want to throw it to my SSE solution or my ZTNA solution. After that has been done, I will throw the other traffic for VPN to the VPN client. So if you have two different vendors, two different clients running on the same machine, your policy set for both network traffic acquisition and security policies have to be defined properly. If not, you will see a great conflict in terms of operations. So you'll be very familiar with this term, software-defined perimeter. ZTNA is just the rebranding of this. So what problems are we trying to solve? Hybrid work, accelerated by COVID, right? We all worked at home for 2-3 years. To be honest, I'm still working from home. I go to the office probably 2 times a month, right? So let me define some of the terms that we're going to see in the industry. Zero trust, so everybody kind of knows this already. This privileged access, continuous monitoring. We do authorization, challenge each and every single access before we grant them into our internal network. You'll see ZTA, I like this one, because there are people who challenge me to say, hey, Jeff, what's the difference between ZTNA and ZTAA? So I'll just say ZTA, and I cover both use cases. But the focus here is around policy, right? ZTA focuses around policy so that you can access these environments. And if you're asking me, hey, Jeff, what's the difference between ZTNA and ZTAA? Well, NA would probably focus more about the whole network. So it might be IoT, server-to-server communication. For the AA, it might be user-to-application specific, right? So that's the main difference. Let's dive one level deeper. But I would say that this might become very, very gray between NA and AA. Why is it so? So if I am doing RDP from my Mac device to a server, is that considered network access because I can traverse the whole network, or is it application access because I'm doing RDP? It's both, so it's gray. But fundamentally, what's the commonality between this? Authentication, I can use things like a SAML. I can add on multi-factor authentication. I can control geolocations, right? I can say, hey, if you're not in Australia, don't allow authentication. Continuous monitoring, so this is important, right? IPS inspection on that connectivity into both application as well as the network. So this is what most vendors out in the market are actually deploying. A client-based agent or agentless. So when we are saying agentless, this becomes very gray again, because some vendors, they install a plugin on your browser. Is that agentless per se? Maybe. They have a helper installed on your endpoint. It's not displaying your taskbar, but it's running as a service in the background. That might be that agent again, right? But okay, regardless of the marketing term, what happens if you have a little helper, that little plugin on your browser? You can actually support additional kind of protocols, SMB, RDP. Where else, if you're actually moving towards a full agent, you can actually support a broad range of protocols and ports, right? So this is great for a lot of different use cases. For example, BYOD, right? A lot of people are actually working on the mobile device, your iPads. Clientless is perfect. But this will not support things like an RDP on an iPad. So I probably have to fall back to full-fledged agent, okay? So let's talk about ZTA when we're actually doing this on a firewall. So in FTD 7.4, fantastic new innovation. We have the ability to do clientless ZTA, and this is going to have SNOT tree as well. Right? You can manage with your FMC, and it actually does not require you to re-architect and change your route tables. Okay? So this is a fantastic kind of feature that we want to actually explore if you have a FTD already on premise. So let me show you this demo setup of how we can actually do this in your environment. So here we are actually running mechatronics.io. So this is my company. And my company says, hey, I want my employees to connect into my company's billing resource remotely because they are out there talking to customers and they need access to this dashboard all the time on iPads. They don't want to carry their heavy laptops all the time. So how can we actually deploy this? So internal, we have an application server, we have a billing portal. We'll set up ADFS here so that we can actually do identity. We have the secure firewall, and users will actually use a browser on an iPad, on a computer, doesn't matter, I don't care. So we'll have the public FQDN. We'll point that public FQDN to the FTD. So this is a config where we actually do a mapping between the external and the internal. So the exact configs will be in the PowerPoint slides. You can refer to it later. I won't run through the actual config. So let's take a look at the demo. Okay? So this is what the user experience will be like. They'll fire off the web browser, and they'll perform authentication, of course. So the FQDN that you see there, publicly accessible, pointing to the FTD. So now Lee is going to use his username and password. And as you can see, very seamlessly, they are now connected into my billing portal. And they can actually interact with the customer, get the data, ask a PO from the customer. But here's another problem. Mr. Lee here is a normal user. And as a normal user, what happens? I'll use one password for both my Facebook and my corporate billing environment. Isn't that common, right? So when Mr. Lee is doing this, I have a problem. Because if Mr. Lee gets compromised by a phishing email, that means that my billing department, my application gets compromised as well. So how can we enhance this by using Duo? So Duo is our secure access solution that actually focuses on verifying device trust, user trust. We have things like passwordless. We have things like the ability to do risk-based authentication. So here you actually see implementing passwordless. So this is the future of authentication. You are already doing it today on your iPhones, on your Androids, fingerprint scan, Face ID scan, you're into your app. So why is it that your corporate application doesn't have this? Ask your IT there. Or if you are the IT, ask yourself, why are you not moving into this? You should be. Why? Because phishing attacks, right? Passwordless is inherently able to prevent phishing attacks for you, right? So this is what I encourage you to look into. So let's take a look at how you can architect your environment to do this. Okay, the components that you need would be your Active Directory on-prem. You can use a cloud-based identity, that's fine. So if I'm using something that's on-prem, I need to deploy a server called the Duo Auth Proxy, right? It can be Linux, it can be Windows, doesn't matter. It can be virtual. And what happens is we actually connect that to Duo SSO. So this is a single sign-on portal available in Duo Cloud, highly available, no other resource required. And essentially, you get an identity provider, IDP. And from here, we actually integrate that with our firewall. So let's take a look at the end-user experience. So again, user fires off the browser. This page comes from the SSO. On screen, you actually see a mobile phone device. MFA is happening here, right? So we actually stepped up security by one step. We have MFA. But you say, hey, Jeff, this is bread and butter. A lot of vendors does this. I agree. But here's the advantage of this. We can actually move this towards passwordless. And I'll show you what it means by moving towards passwordless later. So let's take a look at what happens if Mr. Lee is now a victim of phishing attacks, push phishing attacks. So this is a very common attack that a lot of attackers do on users, right? I'm actually maybe just browsing something else. I'm not accessing the app. Is this a suspicious login? I say yes, because I'm not asking for access to anything. So again, it happens again and again, and it frustrates the user. And what does the user do? They will approve it because it's frustrating them. Okay? So this is what happened to a lot of customers out there, and it's out there in the news. I won't put names to it. You can read the public news, and I'm sure you will know who it is, right? Okay. So how can we actually ensure that we move out of this attack range? How can we prevent this from happening? So as you can see from here, SMS and phone calls are the least secure. Man-in-the-middle attack is going to be very, very sustainable to this part. If you move towards passwordless, web-auth-n, biometrics, using security keys like UB keys plugged into the endpoint, you can prevent phishing attacks. This push bombing attack will no longer happen. In Cisco, we actually have the ability to do something else that's very interesting, trusted endpoints. So what is this trusted endpoints concept? So if I ask you today, do you know if the endpoint that you're using is issued by IT? Some of you might tell me, yes, because it's managed by ICCM, it's enrolled in my MDM. So this is how we can understand if this device is managed by IT. However, it does not prevent the attacker from accessing the system. So how can we actually do this? So we can actually integrate Duo with your Active Directory, enroll it with your MDM, integrate with the MDM, and this will actually increase the trust level of the endpoint. If it's not enrolled in your MDM, if it's not enrolled in Duo, if your endpoint is not part of the AD, I would actually block access to the system. So let me show you what the demo looks like. This device is now joined to domain. And because it's enrolled with Duo, I can actually verify that this is something that we can trust. So we increase the trust level of the endpoint, we actually reduce our attack surface area. Okay? So the users are connecting in now, and you see that now they are required to key in this pin. So this pin is actually a verified push. Prevents the users from blindly accepting the push. So this is one method that we can prevent the push attack on the end user. The other part of it, part of the domain, right? What happens if the device is part of the domain? So here we actually see that the user will actually access the same application. Okay, single sign-on page happens. User keys in the password. So in this instance, the attacker is saying this, sad little face, because the attacker's device is not part of your domain. We have just reduced your attack surface area. It's not bothering your end users, and you have actually increased your security, right? How fast, how difficult is it to do this? Less than 30 seconds, ladies and gentlemen. Less than 30 seconds, you can reduce your attack surface area. That is how fast we can do this. The other part of the story is authentication fatigue. And we experience this day in and day out, right? Connect to the VPN, username, password, MFA. Connect to the application, username, password, MFA. RDP, username, password, MFA. How many times do you key in your username, password in a day? This is resulting in authentication fatigue. And that is why users are accepting push blindly, because it's human nature, it's normal, it's habitual now for you. So how can we actually do this process where we simplify the user's access and make it seamless, frictionless, and easier? So you'll see in this demo, we have multiple browsers, and we are going to use the Duo verified push. Okay, so let's see this. User will actually fire up the same web browser. They'll key in username, password, perform an MFA. Okay, so that's the verified push that we actually see. Okay, done for the first application. Oh, sorry, I think I clicked it. Okay. So the next part of it is we actually are in this pie diagram. We have one browser for first application. We have another browser for MFA access on another application. And maybe for your VPN, you're actually doing another set of authentication. Oops, be careful there. Right. So what if I told you that we can actually remove the need for the users to interact with the second and the app browser in the VPN, right? And we are actually moving that session to something called Remember Devices. And in this Remember Devices, it will actually access whether your device is something that's trusted, and we only authenticate you once for MFA. right? So we can actually do this by configuring the admin experience. We'll say, hey, I want to remember devices based on browser-based applications. I can specify a period of time, 30 days, right? If nothing changes in your endpoint, I will actually allow you to connect without MFA for the next 30 days. You just have to MFA once. And on the end user's perspective, I'll just have this remember sessions in the endpoint client installed on the device. So for this to actually happen, let's take a look at the end user experience. Okay, so now the users are connecting in with the same web browser, and you'll see that the MFA happens the first time. Okay, they're keying in their username, password. MFA happens the first time. They'll key in 957. Yes, trust the browser. So I want them to trust my browser because this policy has been enabled by my administrator. And the next time they are connecting into the next application, you'll notice that it's not prompting me for MFA. Okay, because my session is actually shared between all the browsers. You will not see this very commonly among all the other SSO vendors, right? Usually different browsers, different sessions, different cookies, and that requires you to authenticate multiple times. So here I'm connecting into a second application. The same checks are happening, right? But it's not prompting me for MFA. I'm accessing the second application. And for the third application, let's do a VPN. Okay, AnyConnect is firing up. You see that pop-up browser from AnyConnect is asking me for username and password, but again, no MFA requirement. So that is how we can actually simplify the life of users by reducing the number of times MFA is happening. But you might be thinking, hey, Jeff, okay, that's for the MFA piece, but user have to key in my username password 3 times. How can I simplify that process? The answer is passwordless, right? So with the Duo SSO, it comes with as a passwordless embedded by default. You can use things like Touch ID, Windows Hello. On the mobile device, you can use a Face ID scan, Android fingerprint scan. So all of that is actually built into the solution when you connect it with the Duo SSO. So let's take a look at what happens when I want passwordless in my environment. So here, users are firing off that same application. Sorry. Do you help me play the video, please? Can you help me play the video, please? Yeah, thanks. Okay, so the video is playing now. Right, so we are firing off the web browser, and this time when we are connecting in, you see that users have an email cached over there. Okay, so that is using Windows Hello now. It's not prompting for password, and we're actually connected directly into the application. So this works across all the applications. So you see that we have now one login, passwordless across all applications, one MFA across all the applications as well. And because you're doing biometrics, it's kind of 2-in-1. So a lot of people think that, hey, passwordless is just one Face ID scan, one Touch ID. Does that mean that it is not multi-factor authentication? The answer is no, because it's using cryptographic key exchanges between your TPM chip or your enclave on your Mac, and that's how they are actually doing the authentication, right? So no clear text is actually being passed between your mobile device or your endpoint to the cloud services that's doing the authentication piece. You might be saying, hey, Jeff, now it has become so easy to access all these applications. How can I make sure that this is something that's secure? Attackers can use the same method and they are going to access my systems, right? The answer is no. So this is where we actually put in risk-based authentication. We are actually taking signals from the endpoint. So things like Wi-Fi fingerprinting, things like location IP. Is this an IP address that I trust? Within Australia, the business does not extend out Australia. Anything outside, I want to block this. Is it a known attack pattern? Have I seen this device before? So these are things that we are putting towards machine learning, AI, in order to determine if I want to step up my authentication, if I want to block the attack, or if I want to just bypass MFA altogether. So how does this actually work? So you see here that there is this Wi-Fi fingerprinting. This is something that is unique to Cisco. No other vendor on the market has it. So there's a patent that's pending for this one. And how it works is, you know that IP address, MAC address is easily to spoof, right? We are actually taking signals from access points, be SSID. We anonymize the data, we build a profile for the users, and we compare it So if the user is moving between Australia and Singapore, like I'm flying back to Singapore on Friday, my SSID around me will change, right? It means that Jeff has really changed location. It's an indicator that, hey, maybe this is a risky behavior. I want to challenge Jeff a bit more. So this is how we can actually prove the user's location, and it's not just by IP address, because I can use a proxy to change my location, right? Risk signals, this is very important, right? Unrealistic travel, so I can't travel to Singapore in 5 minutes. It might mean that my credentials are actually compromised. Any of these factors are happening, we essentially block the users from connecting into the applications. So this risk-based factor selection enables us to determine whether I want to block because it's an attack, step up the authentication to passwordless or a verified push because it's something that I want to challenge, or bypass MFA altogether because it's trusted. No change in your risk profile. Why do I want to make you MFA again? So we put the heavy lifting to AI ML, and we actually let the users have a frictionless experience. So here you actually see that there's no change to my Wi-Fi fingerprinting. I'm still in the same location, even if I change my IP address using a proxy. I tested this, right? I changed my IP address, I changed my location, but it still says that I'm right here, and it didn't challenge me. So this is quite interesting technology that you can actually explore. So let's take a look at this high-risk behavior. What happens if I'm using high-risk behavior access? Okay, so here you actually see the same browser access. And what's going to happen is, in this instance, when I'm connecting in, because of risky behavior, it's going to prompt me for a 6-digit PIN. So this is the step-up authentication that's happening. For example, if I'm traveling from Singapore to Australia, and I've not been in Australia for the last 6 months, right? Last time I was here was last year. So it actually challenged me for this because my location has changed, and that's an indicator of risk. However, if I'm actually assessing this from a low-risk environment, let's take a look at what happens. Right, same application. However, this time when I'm actually accessing, So this time when accessing the application, it's just going to ask me to do a normal push, right? So that's the intelligence. So you might argue with me and say, hey, Microsoft has the same thing, right? You key in a PIN matching on the authenticator. However, that's not based on risk, right? It's a static thing. You have to select the correct number, and it's not based on machine learning. So this is the difference between us and some of the vendors out in the market. So what we're trying to do at the end of the day is to eliminate the friction for users to connect in and to frustrate the attackers, not the users, right? So that's where Duo is actually gearing towards, to actually bring more business value for you. So let's move on to Duo Network Gateway. So this is available in our Duo Premier Edition. It is a bespoke ZTNA solution, and what happens is in your DMZ, you actually deploy something called the Duo Network Gateway. This is a Linux server. On top of it, we're installing Docker. It supports protocols such as HTTP, RDP, SMB, and a lot of the TCP protocols. It can be deployed in the cloud as well. So if you have applications hosted on AWS, deploy this in front of it, and you can actually get ZTNA directly into the application. So let's take a look at how we can actually deploy this Duo Network Gateway in the environment. So this is from the previous diagram. We are actually using the Duo SSO for the IDP. It's connected to our FTD. So in your environment, you might not be using FTD. You might be using any kind of firewall. That's fine, right? We actually deploy the Duo Network Gateway. So this is a Linux server running Docker on top. We are using the same SAML IDP of Duo SSO, and we're integrating that with the DNG for authentication. So let's take a look at the end user experience. And it's going to be very, very similar to what you've seen before. Okay. So here the users are browsing to the application again. So again, the FQDN of your public application is pointed to DNG. So a lot of customers ask me, hey, Jeff, now I have an internal application with an external DNS. Is something wrong with you? I say, no, there's nothing wrong. Because all the traffic is going through DNG. We're verifying user trust. It can be a trusted endpoint joined to your domain. I can verify if the OS is updated, the browsers are updated. So I get that security. So this is exactly what Cisco is doing, right? 100K employees, internal applications, that's how we actually access it today. So this is a summary of that two solutions that I talked about today. So what are the main differences between these two? So as you can see, the protocol support for DNG is a bit more. However, you need to install this thing called Duo Connect, a little helper agent installed on your Windows, on your Mac, not supported on mobile devices, so that you can connect to SMB, RDP kind of protocols. The other part of the story is the policy. If you want anti-malware protection, you have to go with the firewall. However, if you're just concerned about device trust, about your OS patches, you can actually deploy the DNG over here. And you see that very big column over there, secure access. So this is the one that has secret sauce. And I'll talk about secure access. So you might have seen the announcement that we made earlier part today that we are entering the SSE market, right? This is what Gartner has defined as the core requirements in terms of SSE. Secure Web Gateway. It should have CASB, DLP, and ZTNA built into it. We do have that secure firewall. So for those of you who are familiar with Umbrella, all that mature capabilities that has been around since the DNS days are still there. DNS level protection, multi-mode DLP, browser-based isolation, and all of this is backed by Talos. So I'm sure you have attended the Talos sessions, right? So all of the threat intel from Talos fed into our security cloud so that we provide the best detection mechanism for any kind of traffic coming in. On top of that, VPN as a service. So this is pretty unique. A lot of the SSE vendors out there, they don't have VPN as a service. So if you have an ASA today, we are going to provide this lift and shift capability to migrate your on-prem ASA, FTD policies, or your configuration directly into the cloud. Why is this valuable? In the future, you don't have to worry about patching your VPN. I don't have to have downtime to maintain it. It's all delivered as a service to all my users. And I can actually layer on all of these policies in one single platform, single SLA, and you can actually have digital experience monitoring. So what is this digital experience monitoring? So the problem with a lot of IT solutions today is, hey, let's blame the network team because they are the ones that always cause slowness to my application, right? So that's a common problem that a lot of IT people experience. So what is the thing that we can use to actually say, hey, it's actually your home Wi-Fi problem. So we have built 1,000 eyes into our secure client, right? And with that, we can actually get telemetry from the endpoint, CPU utilization, whether the Wi-Fi connection is actually good. So all of the apps that the users are using, all that telemetry is fed into secure access, and you have visibility into the performance. So that is how we can actually provide assurance into the whole system. On top of that, I'm sure that you have seen the announcement that Cisco is investing in AI. I don't have that demo here, but we do have a chatbot. So that chatbot is going to be able to create your policies for you in secure access. In the future, we are going to use that to actually run through the firewall rules and optimize. So the problem with a lot of firewall rules is, hey, if we have these firewall rules for the last 5 years, let's not change it because I might lose my job, right? So you just add on new firewall rules when you're doing firewall migration. Let's not change the rules, just migrate wholesale and pray. So how can we save our jobs and save optimization on this? Analyze the rules, look for duplicates, opportunities to consolidate. So that is where we are moving towards, right? So as you can see, this has become a very, very powerful platform. And to add on to that, I'm sure you have joined XDR sessions today. I talked about Duo. You can actually use SD-WAN, Vitella, or Meraki, your choice. So as you can see, a very comprehensive solution. But today, the topic is ZTNA. So I'm going to focus a bit more on ZTNA. So if you're asking me, hey, Jeff, this seems quite interesting. How can I put it into my environment? Let's talk about the architecture. So this is going to be the most simple and boring kind of implementation that you have. Users connect in. You saw the demo, right? It's all very boring. That's why sometimes I'm on stage, I'm like, I'm repeating myself like a broken record. But it is what it is. But this is the advantage of having this solution in your environment. We are connecting to the Windows system. Logging in. Lee is logging into his laptop on Monday. Let's see what happens for Lee when he's using this solution. Lee opens up a web browser. And he's browsing into an internal site. Hey, look at the URL. It's internal. That's interesting. So we can actually proxy the access for Lee directly into internal sites without having to fire off a VPN. And this is the ZTNA piece, right? And how are we actually doing this? So on the secure client itself, you actually see this module. So no more multiple clients from Cisco, right? We want to reduce the number of clients. We are listening to customers. It is a frustration, we know. So we are actually putting that Zero Trust Access module built in. What happens is we will do a one-time registration certificate installed on the endpoint to ensure security, communication, and we will actually support both TCP, UDP applications. And the advantage of this, you can use your own preferred VPN solution. There is no dependency for you to use the Cisco ASA or the VPN as a service in our SSE solution. So that is one of the beauty of it. It complements your existing deployment depending on your strategy. The other part of the story is something a bit more complicated. So what is this quick and mass thing? Anybody watch YouTube? Anybody use Firefox? So if you realize that over the years, your performance when you're watching YouTube and when you're using Firefox is very snappy, it's very quick. Why is that so? And the reason is because Google created this back in 2012. It is a transport layer protocol. The objective of this transport layer protocol is it wants to actually move towards HTTP 3.0 to actually optimize the traffic so that we can all be talking to each other at the same time, and you will understand what I'm trying to tell you. That is the objective of the protocol. Minimize collision, optimize the flow of it, and it's going to be zero latency. And I do not have to do a three-way handshake. So you know server and client communication, we have to do a three-way handshake before we can start sending packets. If my packet drops, I have to resend all over again. That's not going to happen with this protocol. And the other part of it is mass, quick. So this is basically a proxy technology that rides on the quick transport layer protocol. So why do we want to use this? It's really fast, zero RTT. Really fast, really efficient. And you can actually send multiple paths at once. Right? So this improves the performance. This is the other part that I really love, native OS support. So I, myself, I'm a huge Apple fan. I have 2 iPhones, an iPad, and a Mac. I know, Singaporeans are crazy about our iOS devices. Every year we change to the brand new ones. It's natively supported on iOS, ladies and gentlemen. What it means is from your device itself, I can now use the backbone of Apple and connect into my corporate applications. How fantastic is that? Right? So this was announced at the W3C this year, that Cisco is in partnership with Apple to actually bring this technology to you. So with this, we can actually support all ports and all protocols, which is fantastic. So let's take a look at the endpoint experience. iOS device, our files, okay? This is a SMB application. So you see that the application fires off, and you're able to browse into internal resources on the SMB file share seamlessly, right? So at the back of this demo, you'll see that all of this connection is happening over a secure connection of the private relay. So here we have RDP. So you might be thinking, hey, I already have Citrix, I already have VMware. Can I replace that with such SSE ZTNA technology? Answer is yes. As you can see from here, with the RDP client on my iOS device, I'm connected to a remote desktop session, right? Similar to VMware, similar to Citrix? Yes, it is. Again, this is going to be that same portal that we've been showing since the start, the Blink portal, seamlessly, ZTNA, clientless. And here we're actually connecting to another application, right? We are actually performing passwordless. Yes, you can passwordlessly access your internal enterprise application when you actually use Duo in this architecture. So again, we are actually here in the dev lab. And let's take a look at the connectivity of this guy. Right? You see VPN and relays, and when we actually browse into this, you actually notice that the server there is using this proxy, and the proxy is pointing to our SSE solution. We have a whole bunch of domains that we have whitelisted over here. So all of this is running through the private relay of Apple. Right? So this is a technology that you want in your environment to invest in this technology because of the speed, stability, and the ability for it to run multiple pods and protocols. So this is the snippet from W3C, WWDC this year. Right? So have a read on this. I think it's pretty interesting. Okay, so you might be asking me, hey, Jeff, under the hood, how does the application know when do I use ZTNA, when do I use VPN, who intercepts what traffic on the get-go, right? So we are actually using socket interception. So the ZTNA would be the first layer that intercepts the traffic. We determine whether the FQDN belongs to something on our SSE platform, or it's belonging to something that, hey, might need a VPN connection. So we throw it to the VPN client, and this can be third-party VPN. And the VPN takes care of whether it talks to the physical or the virtual interface, and all the routing happens independently based on the type of module. Okay, so let's take a look at this demo, right? So in this demo, we have ZTNA based on our secure access solution, and the VPN is going to be OpenVPN. So here you actually see that the AnyConnect client is not turned on, ZTNA is registered, and we have the OpenVPN client over here. Okay, so we're going to do connectivity into the environment. Okay, so in this instance, what's going to happen is we're going to do an RDP. So RDP is firing up, all good, through the ZTNA. And for the other part, we're going to have the application as well. Yeah. So you can actually coexist with different solutions if you just want the ZTNA module from Cisco. So this is kind of what I want to advocate to you, right? You've been using the same access method for the last 3 to 4 years. If you say no to me, I'm happy for you, because it means that your IT department or you yourself as IT, you have decided to change and evolve. So you can actually move from traditional VPN to VPN as a service. And you can think about how can I modernize some of my application access, right? Move it to ZTNA. Why? Because Zero Trust is inherently built into this architecture. You use modern protocols, performance is ideal, best, and you can use it over iOS. I get questions to say, hey, is Android on the roadmap? Yes, Android is on the roadmap. That's being worked on, not available today yet. So this will actually allow us to become more identity-centric, to actually preserve our security, and to actually have a higher level of implementation in terms of security. So how can we actually do this in our environment? So our secure access solution is built into the cloud. There is a data center here in ANZ, so that's fantastic. From the end user standpoint, we would have the Zero Trust Access module here. We'll use MassQuick for private applications. It connects into our cloud environment. So we perform authentication based on SAML. You can use dual password alerts into the application. And from there, you do posture. So yes, you can do posturing. Things like, is your OS updated? Is your browser type permitted? Right? If you want, we can also check for endpoint security. From there, layer 3, 4, 7 firewall inspection before they actually connect into the application. So how can we do the back-end connection to the applications? You have two options. Option A, you would do an IPsec tunnel from your routers direct to our cloud environment. So this would actually help you do auto failover BGP, or you can actually choose the app connector option. App connector options has two deployment models. One is app connectors on AWS. That's going to be the first edition. We will have the on-prem very, very shortly. So what does that mean if I choose the app connector option? This is fantastic. I'll tell you why. When I'm deploying such solutions, customer complain to me, I have to change all my routing tables. I have to open up a bunch of firewalls because I have a bunch of applications, different protocols. The complexity of the firewalls is killing me. Is there a simpler way? Yes, there is. And why do we want to do this? Outbound 443. DTLS tunnels built based on this. I don't have to change my routes. I don't have to change my firewall too much. 443 is probably already permitted in your environment. Fantastic, right? Makes things simple. What do I need to do on my endpoint client? Upgrade it to the latest version of secure access. Do an enrollment. I'm done. So this is kind of the summary of the different ZTNA options that Cisco offers, right? As you can see from here, our secure access solution is SaaS-based. There are a lot of use cases that you can solve with this. Client to client, you see that. This is very unique, right? The rest of it doesn't have a client-to-client kind of use case here. It uses fantastic protocols, MassQuick over TLS. And you can actually have a whole bunch of other security posture controls. RBI, DLP, CASB, everything built into one deployment. So I encourage you to pick the right ZTNA solution, think about whether you want to couple this with your SSE strategy, and to actually evaluate the solution properly before deploying. So with that, I kind of come to the end of my presentation. I will be at the Ask the Expert session, so if you have further questions, please reach out to us, book a slot with me. And I would really, really appreciate if all of you can give me feedback. It will help me build better content for next year. And if you want to learn more, there are various resources. We can reach out to any of the Cisco folks here. So with that, I thank you for your time. I'll be here if you have any questions.